Hi, my dear students, welcome back to the video where we are discussing issues about the exponential equations and logarithmic, but rather we have started up looking at the exponential equation as such. So for those who are joining us for the first time, please try to bear with us that what we're doing here, we are talking about the exponential equation. So if you have not captured this concept, can you first of all revisit the previous video that we have discussed with your friends, so that what we do here should mean sense to you. So there's a line down here, the link down here that you can use to at least connect yourself to the previous video. Right, all in all, what we are doing here, we are continuing with the previous topic about the exponential equation. Right, so exponential equations. Right, so in the previous video, we defined what an exponential equation is, and this time around, I think everyone knows how to model up the exponential equation. Just maybe the introductory part is important. That's say all equations which are in the form like a y is equal to h to the power q, whatever, talk of arrangement of the variables in that equation. Such equations are referred to as exponential equations. Right, you'll be able to define these variables as y being a number under discussion, while h, this one is referred to as a base. That's just like a factor of y. This means h can get into y in this case. And the q, that one is defined as the what? As the exponent, or call it the index, or else call it as what? A power. So this presentation is the equation is defined as the exponential equations. Q exponent tells you how many times are you going to multiply h in order to get what? Y. That's the understanding here. So I multiply h q times in order to get what? Y. That's the thing. So the h is defined as the base, while q is defined as an exponent. So as such, the entire equation here formed from the base, exponent, and the number under discussion give us what is known as the exponential equation. Right, so last time we ended where we were looking at some of the examples on how we can solve the exponential equation. So this time around in this video, we're also going to do the same. We'll finalize on the how best we can solve the exponential equation. There's several of them, right, to express in such manner. But what the underlying feature here is just a matter of knowing how to treat such type of equations. So from what I mentioned that time, and how we can solve the exponential equations, I just indicated just a simple statement here that you should be able to go along with. Just simply consider expressing terms to the same basis. That's all. Expressing expressing terms to the same basis. Or another situation where you cannot mind to express them to the same basis, then you have to target the what? Exponents. Right. So that's it. So we'll be meeting up different type of situations where maybe it is again not possible to do that. You can even change the base. You see, revise the two examples we have had in the previous video, but then down here. Right, now today what do we have? Let us look at these examples. That's the example. Solve the following. Equations. Number one, we have got 8 raised to the power, or say exponent to 3x minus 2 is equal to 4 raised to the power 2x plus 1, b 4 raised to the power 3x, that's a 2n minus 1 is equal to 1. And lastly, we have got this form of an equation, that's a 2 to the power 2x minus 3, open brackets, 2 to the power x plus 2, then we close the bracket, plus 32 is equal to 0. Right. So that is what we have here. Of course, this other one, that's the last one, is just more like an applied type of problem, but still more have to venture into that. So by the condition, or say the talk of the procedure expressing the terms to the same basis, how do we handle example A, whose equation is 8 raised to the power 3x minus 2 is equal to 4 raised to the power 2x plus 1. Right. So here we will be able to see that, say, the left hand side, the base is 8 and the exponent is 3x minus 2. On the right hand side, you find that the base is a 4 and the exponent is 2x plus 1, expressing terms to the same basis. In this case, find that that's not possible to express either 4 to base 8 or 8 into base 4, because firstly you need to consider the existing base if you like to convert the terms to the same basis. So it's not possible to do any one of those presentations. Right, so now what is it that we're going to do? So as I mentioned earlier, by the examples, we had the second example in the previous video, you'll be able to notice that if we can consider 8 and a 4, you can find that the two bases, those numbers can be at least expressed to a particular base, the same base. In this case, you'll be able to see that 8 can be expressed to base 2 and 4 can also be expressed to base 2. So in such situation, you can change the base. Right, so instead of having this one to any one of these bases, then what I'll do now, I'll change 8 to base 2. So it'll be like, now, how many 2s should I multiply in order to get 8? So you find that we have got 3 2s to be multiplied to get 8. So what am I going to do? I'll write 2 to the power 3. Then here, there's already a power, which is this exponent in the form of expression. It means this 3 now has to multiply by that expression up here. This is already an exponent. So I'll write be a 3x minus 2. That's the way you're going to present your write-up. On the right-hand side, since I've chosen the base 2 on the left-hand side, I'll also be able to see that I'll be able to notice that this 4 can also be expressed to base 2. So it's like, how many 2s do we multiply in order to get a 4? So you notice that there are 2 2s to be multiplied in order to get a 4. So I'll write 2 to the power 4. 2 to the power 2. But since up here they have already the exponent, which is 2x plus 1, so it means this 2 has to be multiplied by 2x plus 1, which is already up there. So that's the situation we have here. 8 and 4 that have been expressed now to base 2s. Then now, by the rule of, say, since bases are the same in the equation, it means the exponents 2 must also be the same. So it means 2 to the power 3, open bracket 3x minus 2 is equal to 2 to the power 2, open brackets 3x plus 1. As long as the bases are the same, then we have to expect that, say, 3x minus 2, that should be the same as 2, open brackets 2x plus 1. As bases are the same, exponents must also be the same. Right, then what do we do? Here we have got just now a very simple linear equation. Let's just remove the brackets by expanding. So here we have 3 multiplied by 3x, we have got 9x, then this multiplied by 2, we'll get negative 6. And here we have got 4x, then plus what? Plus a 2. Then what do we do? Here, I think it's just like historical, just arrange like terms together, where on the left hand side I've got 9x, and here we have got 4x, which should come to the left hand side, we get negative 4x, right? To the right hand side, what do we have? A 2. And this a6 goes to the right hand side, where we have got positive 6. Right. Then from there, what do we have? 9x minus 4x. This gives us 5x. and 2 plus 6, this gives us 8. So finally, on the first example, what we have here is 5x is equal to 8. To find the value of x, we divide by 5, we divide by 5 on both sides. So 5 here and 5 there they go, and x comes in as 1.6. Because 5 gets into 8, 1, remainder 3, you add a 0, get a 30, 5 into 30, get a 6. So in the first equation, the value of x there is 1.6. And later, if you are going to substitute for 1.6 on the variable x, you'll be able to find that when you simplify the left-hand side and the right-hand side, the values will be the same. Right. Now let's go to example B. This is example A. Try to notice what we have done here and master how we have handled that one out. Example B. Here we have terms like 4 raised to the power 2n minus 1 on the left-hand side, and the right-hand side here we have got a 1. Right. So it's like in that case, if they say solve the equation, then definitely what they want us to do there is simply to find the value of the variable. In this case, the variable n. Right. So by the same procedure of expressing the term to the same basis, you find that here again is also not very direct, that you can just take that base into what maybe base 4, this one is also be a base 4 and like. We need at least to do some kind of application. Left hand side is 4 to the power 2n minus 1, right hand side is 1. Right, so we can be able to sometimes think and try to consider of the past experience in JCE, where we had some topics, we read about the laws of indices and like. You'd find that in this case, if I would wish to express this term and that term to the same basis, I can tamper with a 1 here. Right. Any value of 1 is just as good as having any number expressed to the power as a 0, or any variable or any expression that is expressed to the power 0. That is as good as writing a 1. So I can capitalize now on that one. Since here I've got a 1, then now I'm varying to make the terms the same basis. The difference, as far as here the base is a 4, I can be able to convert 1 into base 4 by just having 4 raised to the power 0. Because what I know is just like every expression or every term that is raised to the power 0 is a 1. So here it means this one can be also expressed to base 4 very easily. So it means on the left hand side I have got 4 raised to the power n minus 1. Here it will be 4 to the power 0. So that's what we have there. So 4 to the power 0 is as good as writing a 1. Bases are the same on both sides. Here's a 4, here's a 4. When that one is true, it means 2n minus 1 should be equal to 0. Bases the same, it means the exponents must also be the same. So that's what we have there. So now, here, what do we do? Like terms together. You have a 0 and a 1. These are like terms. So you transfer a negative 1 to the right hand side, where you have 1. Now, negative 1 now will be positive. While on the left hand side, we have got 2n. And here we have got 1 and the 0 give us a 1. And then to find the value of n, what do? Just divide by 2 on both sides, and you have your n as equal to half or 0.5. Right. So the underlying idea here is just like get to know how you can deal with your 1. So this is just 4 to the power 0. Right. So I think you are able to master the way we are using that statement of expressing terms the same basis or say same exponents as such. So this is the way it goes. Lastly, what if now we are given an applied question like this one down here, where we need to find the value of x. To have 2 to the power 2x minus 3, then 2x plus 1, and the exponent then here plus 32 is 0. What is the value of x? Right, so without wasting time, can we work out on this one? Right, so we have example C here, 2 to the power 2x open bracket, not open bracket, this is just like an exponent as such, then 3 open brackets, that's 2 to the power xc plus 2 plus 32 is 0. Right, so this equation here cannot be realized as we have been doing the other problem there. We may not be in the position to find the value of x, but rather to deal with such type of equation, other applications must come in. So the student should be able to understand that, say, it's not always that questions always come direct as in the examples, but they would still need you at least do some kind of a little bit of application of some kind. So this is one of the equation. So there it needs you to think and reason. It doesn't mean that things will just come direct as such, no, but you need at least to think and come up with the issues about logic based on the past experience. What is it that I've already done in the past? If you feel like that problem cannot be solved directly as such. So as a student, try to consider to say here is they have got an exponent which has got a variable x, and I want to take it down and get the value that is representing that. So this is about just reasoning and applying up some concepts of the past. So like here, in this case, how do we come up with the value of x? Like, so without wasting time, since we're direct here, I know you can be able to think it's similar experiences. In this case, what is needed or required of you to do is try, first of all, to come up with the presentation of some terms in here by a particular variable, because this cannot be worked out directly as such. You can develop a different type of equation, you use it, that one, in order to find the value of x. Like, say, for example, in this case, you can bring in issues about what we call the quadratic equations. Right. I've said some amount of thinking, reasoning. How do you come up with such decisions? You think, you figure out the terms in the equation the way they are. I cannot solve it out. By sitting down, thinking, reasoning, you can come up with the ideas. Like, say, for example, as I'm talking here, I'm talking again, for example, the idea that can help me to find out the value of x here is an issue about changing this equation now into quadratic equation. Right, that is one way how one can think. So now, just like now, how does this idea of quadratic equation can come about in order to help us find the value of x? Right, so what is here is just like presenting some terms in there by a particular variable. But first, what you need to know here is that the moment we have written like 2 to the power 2x, this is as good as rewriting that one into 2 to the power x, then open bracket, that one has to be multiplied by a 2. Because you know for sure when you have got a power outside the bracket, or inside you have got the term which have got a power, that's as good as multiplying this one by this one. So when I write this one, if the 2 outside is as good as writing 2 to the power 2x. Right. Then here I have got a 3. If I look at inside this bracket here, I've got 2 to the power x plus 2. I'll be able to at least theorize in my mind and be able to think and understand that, say, this presentation here of 2 to the power x plus 2 is as good as writing 2 to the power x multiplied by 2 to the power 2. Remember, when we multiply terms to the same basis, what happens? We just add the what? The indices. So 2 times 2, okay, sorry, 2 as the base, 2 as the base, I multiply. Okay, this term has got the 2 at the base, this term has got the 2 at the base. So the two terms are multiplying, they are of the same basis. So what you do here, we just add x plus a 2. That's what we have here. So this one is as good as writing this. So here, you just add what? 32. And here you have what? A 0. Right. So now if you can sometimes try to simplify here and there, you'll be able to note that, say, this one, you can still leave it as it is first. You have 2 to the power, talk over 2 to the power x squared. Here, minus what? 3. And in the brackets, 2 to the power x. And this has to multiply by what? This is just as good as multiplying by a 4. Plus 32 is equal to a 0. Right. So this is more like 2 times 2 to the power x times 4 plus 32 is equal to 0. So which means this 4 can multiply by 3 to give us 2 to the power x squared minus 4 times 3. This gives us 12 times 2 to the power x plus 32 is what? Is a 0. Right. Now, from there, what is it that we do? Remember, I talk over issue about the quadratic equation. So how do I bring an issue about the quadratic equation? So what I'll do here, I will need to represent this term here, x to the 2 to the power x, and here again 2 to the power x by a certain variable. Like say, for example, I would say let 2 to the power x be equal to maybe y. Because directly there, it may not be true for I, or say easy to wake up with the value of x. So now what if I represent that expression or that term by a variable, any variable like say y. So if that's the case, what do I have? It means wherever there is 2 to the power x, I'll write a y. So here 2 to the power x squared is as good as writing y squared. Then here minus 12y, then plus what? 32. So you can see this is a quadratic equation that we have just produced. So I know already how to solve the quadratic equation. So what can I do there? I'll just follow those principles of solving quadratic equation, where you tell me first thing I have to multiply that one by that to have my 32y squared. This is just like factorizing the left hand side of this equation. So what do? I need now to find the factors of this one that when I add can give me negative what? 32y. So factors of 32 y that can give us the negative 32. Okay, factors of 32y squared that can give us negative what? 12y. When added, you'll be able to notice that there are negative 80y and negative 4y. Negative 8y times the negative 4y will give us positive 32y squared. This plus this will give us negative 12y. So I add here plus 32. Right, I get that. So I take it for granted that you already know how to factorize the quadratic expression. This time around, I think you should not struggle by that. We have already done something about factorization, and we have already done something on how to solve the quadratic equation. So this one should not give us some kind of headache. So here what do? We go by grouping. So this one group, this another group, right? So let's identify the common factor for this one and that one, and you realize that is y. So y here give us a y minus 8 here. Y cancels y, give us negative 8. The same common factor for this one and this one, so that the result should be y minus 8. You notice that the common factor is negative 4. Negative 4 here is y, and here is negative what? 8, and this gives us what? 0. So at the end, if you see that you have got this situation on the left hand side, you'll be able to notice that we have got a common factor for this one and this one, which is y minus 8 as the common factor. So when y minus 8 gets into y minus 8, then that is y, because this one cancels with this. And again, y minus 8 cancels with y minus 8. The answer is negative 4. So that gives us a 0. That's it. So by what we discussed in the first topic about solving the quadratic equation, we said that this time we are multiplying two brackets and they equate to 0. That is as good as writing each one of them. Y minus 8 is 0, or talk of y minus 4 is 0. So when you solve this one out, what we have, just like say y is equal to 8 or y is equal to 4. We have got two values of y in that case. Right, but now these are the values of y. But our equation does not contain a y. So what we do there, we come back where we said let y be equal to 2 to the power x. So we're going to form two equations here in this case now, which are now exponential. So instead of having y is equal to 8, now we'll have 2x is equal to 8. Or y is equal to 4. So instead of having y is equal to 4, we realize that say y was represented as 2 to the power x. So here it means we have got 2 to the power x is equal to a 4. Right. So it means in this case we are going to solve two equations. So this is already exponential, this is another exponential. So through exponential equations, the same principle has to be applied, express them to the same basis. So here the base is a 2. 8 can also be expressed to base 2. It's possible. So let me do that. To the power x. How many 2's do we multiply to get 8? You find that we have got 3 2's. So here you also have 2 to the power x. And ask yourself, how many 2's do we multiply to get a 4? You talk of 2 2's and write them on top with the number of times. I always indicate on top. So as much as the bases are the same here, then we're going to conclude that say x is equal to a 3. Or here, the second equation, you have got x is equal to a 2. Then finally, you just have to conclude that say x is equal to a 3 or a 2 as your final answer. Right. So that's the kind of application I wanted us to notice together. That there's some problems where it needs us just a little bit of additive. So the additive here is just like the quadratic equation where you introduce the variable and you play the game like that until the end you have the value of the variable as 3 or 2 as such. Right, this time around, thank you very much for being together. But before I leave, can you have this one that we're going to do it at your own free time? Before you venture yourself into the next video that we are going to discuss very soon. So can you solve me this one? 2 to the power 2y minus 5 open brackets 2 to the power y. Then this one should be added before the answer is equal to 0. The equation gives us equal to 0, like that one. 2 to the power 2y minus 5 to the power y plus 4 is equal to 0. What is the value of y in this case? Right, but all in all, thank you very much for being together. We meet in the next video where I'll introduce you into the logarithmic equation. Thank you very much.